Chapter 9, Section 4, Multiple Regression Analysis. After the previous video, what I have talked about is bivariate analysis, where only two variables are included. In this section, let's focus on regression analysis containing more than two variables. Specifically, I will talk about a regression analysis that contains two or more independent variables. Regression analysis we have seen so far have only one independent variable. They are called simple regression analysis. But in many real cases, a dependent variable depends on multiple factors. So, regression model should contain two or more independent variables. Regression analysis that contain two or more independent variables are called multiple regression analysis. A regression equation of a simple regression contains only one independent variable. On the other hand, that of a multiple regression has two or more independent variables. Let's look at the regression equation of multiple regression in detail. Here, y represents the dependent variable. Beta 0 is the intercept. It will be fixed as a constant value. This equation contains three independent variables, x1, x2, and x3. The beta 1, beta 2, and beta 3 are regression coefficients of each independent variable. There are two or more independent variables in a case of multiple regression, so each regression coefficient partially explains the dependent variable. So, regression coefficients are called the partial regression coefficient in multiple regression. Partial regression coefficient represent the impact of the independent variable when we keep the other independent variables constant. So here, beta 1 represents the amount of increase or decrease of y when x1 increases by 1 and x2 and x3 do not change. In the statistics use of term, we often say that a variable's partial regression coefficient represents the impact of the variable when we control the other independent variables. If the partial regression coefficient is positive, the increase in the independent variables leads to the increase in the dependent variable. If the partial regression coefficient is negative, the increase in the independent variable leads to the decrease in the dependent variable. If the partial regression coefficient is 0, the increase or decrease in the independent variables does not affect the dependent variable. And the absolute value of the regression coefficient reflects the size of impact of the independent variable on the dependent variable. Let's look at an example. Suppose we have an employee dataset that records employees' attitudes and their perceptions of our company's human resource practices and work environment. We develop a multiple regression model to explore the major causes of work engagement, one of the positive work attitudes. So, in this model, work engagement is the dependent variable. And we use 6 independent variables: employees' perceptions of human resource development practices, peer support, formal support, work environment, compensation, and peer relationship. Detailed explanations of these constructs are not our focus here. So, let's go on to the result of this regression analysis. We can implement multiple regression analysis using various tools like Python, R, Microsoft Excel, and so on. Since they output the various metrics, beginners may be confused how to interpret the result. So, let me show you the major metrics we have to focus on. This is an example of a result of multiple regression analysis, as we saw in the previous slide. The row represents the intercept of regression equation and independent variables. First, we need to check the p-values. We need to check whether the p-value for each independent variable is lower than the significance level. If we set the significance level to 5%, the p-value should be lower than 0.05 to be statistically significant. Except for compensation, all the independent variables have significant effects. The p-values are computed based on the t-values, so t-values are also important. But the p-values are more intuitively understandable, so it is better for us to focus on the p-values to check the statistical significance. Next, we need to check the partial regression coefficients and their valence and absolute values. They provide us with the information of effect size. As we can see, work environment is the most impactful variable, and it has a positive effect on work engagement. On the other hand, peer support is less impactful, even though its effect is statistically significant. And we should regard the coefficient of compensation as zero, because its effect is not statistically significant. These three metrics are used to evaluate the statistical significance and effect size of each independent variable. On the other hand, the three metrics at the bottom is used to evaluate the regression model as a whole. Adjusted R-squared represents the proportion of the variance of the dependent variable that is explained by the independent variables in the regression model. Simply speaking, it represents how well the data is fitted to the regression model. If it is 1, the data is perfectly fit the regression model, so the predicted values of the dependent variable are perfectly the same as the observed values. If it is 0, the predicted values of the dependent variables are no better fitted than the average of the dependent variable. I will provide you with more detailed explanation of this metric in the next chapter. F statistic represents whether all the independent variables are 0. It is a test statistic of F-test, which proposes a null hypothesis that all the independent variables are 0. So, the alternative hypothesis is that at least one of the independent variables is not 0. Here, the p-value of F statistic is lower than 0.05, so under the 5% significance level, we can reject a null hypothesis. It means that one or more independent variables in the regression model have statistically significant effect on the dependent variable. Using the result of a multiple regression analysis, we can create a scatter plot like this. The dot represents each independent variable that has significant effect on the dependent variable. The horizontal axis represents the regression coefficient that each independent variable has in the regression model. The vertical axis represents the mean value of each independent variable. Variables located in the upper right area have a large impact on the dependent variable and a high value. So, if they are positive traits, they can be the strength of the organization. But if they are negative traits, they should be improved with high priority. Those located in the lower right area have a large impact but low value. So, if the variable represents a positive trait, it means that the organization needs to make intervention to improve it. Improvement in those located in the left half area should be less prioritized. As we have seen, Correlation and regression represent a linear relationship between variables. What we should keep in mind is that they can quantify linear relationship only. So, even if we observe almost the same values of correlation coefficients or almost the same regression equation, we cannot conclude that they have similar relationship. Let's look at a famous example called Anscombe's quartet. Here, we have four pairs of variables, x and y. All pairs have same x's mean, y's mean, x's variance, and y's variance. And the correlation coefficients between x and y are also the same. Moreover, the relationship between x and y can be expressed by the same regression equation. So, from the quantitative metrics, these four pairs seems to be the same dataset. Let's create a scatter plots for these four pairs. You can see the data distributions are widely different. So, we should not only rely on quantitative metrics. Anscombe's quartet tells us the limitation of quantitative metrics and the importance of data visualization. Let's summarize the points in this chapter. To quantify linear relationship between variables, we can use correlation analysis and regression analysis. But they cannot quantify non-linear relationship. So, the use of correlation and regression analysis is sometimes not enough to capture the whole picture of the data. So, data visualization is also important. Correlation analysis and regression analysis are similar, but they are different. Correlation analysis examines the degree to which data can be approximated by a straight line. Regression analysis examines the degree to which the x's change impacts the y's change. Both correlation and regression analysis are useful in exploring cause and effect relationship between variables. However, we should know that both correlation and regression do not confirm a causal relationship. Thank you for watching. Please thumbs up and subscribe to my channel.